Here's your problem. The function f of x equals 3x to the fourth minus 7x cubed minus 9x squared plus 24x minus 4 has at least two rational roots. Use the rational root theorem to find those roots, then proceed to find all complex roots. Note, roots may be integer, rational, irrational, and/or complex. This is that same polynomial here. This is your answer. These are all roots. I wanted to show, I have a picture of a random graph right here. It's just a random graph I chose. This, and this are all roots. Roots are where f of x is 0. So roots are where f of x equals 0. So if you make this 0 and solve for the x's, roots are where x's are at, where y is 0 or f of x is 0. Roots are the same thing as the x-intercept, solutions, or zeros. These are all different ways to say the same thing. We're using the word roots in this situation. She wants you to use the rational root theorem. So moving down, the rational root theorem is a way to find roots for complex polynomials like this one. So you're going to use the rational root theorem since it's a complex polynomial. You can't just factor this one. So step one, you're going to list all the factors. You're going to list all the factors of 3 and negative 4. The leading coefficient with the highest exponent. The leading coefficient is 3, and the constant term is negative 4. I have the negative 4 here with the factors, and the 3 here with the factors. 1 times 3 is 3. Negative 1 times negative 3 is 3. And I do the same thing here. Negative 1 times 4, 1 times negative 4, 2 times negative 2. After you get the factors, you're going to move to step 2. You're going to put all these factors, negative 1, 4, 1, negative 4, 2, and negative 2, over top of all these factors. That's your 1, 3, negative 1, negative 3. And I just put them in numerical order. Negative 3, negative 1, 1, 3. So you put all these factors on top of all these factors. Then, after you get this, these are all the possible factors, all the possible roots. Step 3 is you're going to list all possible roots from here. And this top one is the result of that. I just took this negative 4 and put it over all these numbers, 1, 3, negative 1, and negative 3. That was for the negative 4. And then I just used the negative 2, and I did the same thing. Put it over the 1, the negative 1, the 3, and the negative 3. I did the same thing for the negative 1s here. I didn't do the 1, the 2, and the 4 because it's the same thing as these except for negative, and I already have those highlighted. I already have those. And then this second row is just simplifying. Negative 4 over 1 is negative 4. Negative 4 over negative 1 is 4. Negative 2 over 1, negative 2, and so forth. So this row right here is all the possible roots. And this, you take all these possible roots and you move on to step 4. Step 4 is where you test to see if these are roots using synthetic division. And you know that they're an actual root because when you do synthetic division, the remainder will be 0. Remember, synthetic division, you take this 3, negative 7, negative 9, 24, and negative 4, and you put them here. 3, negative 7, negative 9, 24, negative 4. The first one I tried was a number 1 because that number 1 was down here. It was a list of a possible root, and so I tried the number 1. When I used synthetic division, I got a remainder of 15, so this was not a possible root. Then I moved on to number 2 because it was another easy number to try using synthetic division. I used synthetic division. I got a remainder of 0. That is a root. So I know 2 is a root. That's how I got this x equals 2. That is one of your roots. After you get one root, it gets easier because you no longer have a power of 4 here. It goes down by a power, and you're just left with these numbers here. So you're just left with 3x cubed minus 1x squared, or just minus x squared, minus 11x plus 2. So then you can just use this simpler one for synthetic division. Now I tried negative 2, got a remainder, 4. I knew I was going to get a remainder, so I stopped. Negative 1, I got a remainder. And then I kept going because I didn't find the next root yet. So I tried negative 4. I knew that was a remainder. 1/2, 4/3, 1/3. I was getting desperate. Negative 4/3, negative 1/3. And then I thought, wait a second, 2 could be there twice. And so what I did was I tried 2 again because I tried 2 again, and I did use synthetic division. I got a remainder of 0, and so I knew that again was another root, but it's already listed as x equals 2. But what that did is that gave us a quadratic formula now, 3, because we reduce the cube down to a squared. So you're left with 3x squared plus 5x minus 1 equals 0. And that is easy because then you can just use the quadratic formula on this. And so for this one, it's the opposite of b. Okay, having trouble here with bringing my screen up all the way. But it's the opposite of b, plus or minus the square root of b squared, 5 squared, minus 4 times a times c, that's a negative 1, all over, and you can't see this down here, but it says 2 times 3. It's 2 times a, the 3. 2 times 3 is going to be 6, and that's what you see over here. So then I start simplifying. The negative 5 stays the same, plus or minus the square root of negative 4 times 3 times negative 1 is positive 12. All this 5 squared is 25. And this simplifies to 37 underneath the radical. So negative 5 plus or minus square root of 37. Negative 5 plus square root of 37 over 6. Negative 5 minus square root of 37 over 6. And you can't see the 36 here, or the over 6 here, but it is. And those are the 3 roots, as you can see.